I'd like to introduce our first keynote speaker. When does Nate splits are really
Do you want me to go until 10?
No, that's good.
10.
So I'll give you
Just hit the gong.
that loud one out there.
Yeah.
Okay. So Bonnie is a systems engineer with Naval Postgrad, and she will be talking about, managing tactical complexity for military problems using metacognition. There's a lot of the history of this event is related to military funders. I thought this would be a nice way to start the day. So Bonnie?
Okay, thank you. So I'm not the loudest speaker, but it's a small room, so I'll try and project as much as I can. Okay. So I work for the Naval Postgraduate School, which is located in Monterey, California, but I live here in Maryland in the DC area. So I've been a distance learning professor there for 15 years. I'm not a computer scientist, so I am a professor in the systems engineering department. And all right, so let's see. How did I stumble upon metacognition? So I got involved, so I've been working on automating decision aids to help warfighters make mainly decisions about whether or not to fire a weapon for about 25 years. So anyway, so I've been working on that for a long time, longer than even having been at NPS. But the word artificial intelligence kind of came back into vogue, at least, in my systems engineering world and across DoD. I want to say probably around the year 2018 or so. So before that, we were really looking at big data methods and other methods. But anyway, so these are kind of a list of questions that I kind of pose to my students and research group, and these are kind of the things that kind of drive us. So basically, just at a high level, how will AI in general benefit the warfighter? Which methods are appropriate? So we've done several studies on mapping different AI methods to the kill chain, which, if you're not familiar with that, is the whole process of deciding that there's a threat, deciding how to respond, choosing a particular weapon, maybe to hopefully intercept or defend against that threat, and then assessing whether or not you've been successful. So it's that broad, and of course there's a lot more to it than that. We've also been looking at it kind of more in the mission planning phase. So as we're planning missions, maybe in the coming day or coming weeks, or even in some cases coming months or years, how can we use AI to help with that? And then this big one here, how can we ensure AI is safe? That question right there is what led me to this field of metacognition that I've become very interested in the last couple of years. But we've also been looking at things like how do warfighters interact with AI and trust AI, also what systems engineering methods are best to help develop AI, and then more broadly, how will AI benefit the Navy, since I work for the Naval Postgraduate School, and then what might future AI, participatory military concepts of operation look like. Okay. So this is just to give a sense. These are not all the studies that I do, but these were kinds of ones that were AI related. So we do a lot of studies that last for about a year or so. And basically sponsors in the Navy at ONR and at OPNAV and the Pentagon and so forth, and different commands kind of come up with some study question, and then we get to work on them if we're lucky. So anyway, so these are just some, to give you a sense of some of the ones that I've been working on. I mean, this one in pink, this one in the year 2021 is what I was working on when I came across this idea of metacognition. All right. So basically, and I had a student group helping me with this and some research colleagues, but we started just looking very broadly, because we're systems engineers, and we're looking at problems holistically, to say what are some safety issues that could creep in as we someday have, AI making weapons decisions or functioning in autonomous systems and so forth. And so remember, this was back in 2021, but just looking broadly across how humans might interact with AI systems, dealing with uncertainty, of course, bias creeping in, other issues. And so then we also kind of posted in terms of what might some specific failure modes be. And so those kind of largely were grouped into, hey, as we automate more things, then down here is a whole example of how adversaries could take control of our AI systems or inject bad, corrupt data or do some different things in that way. Another whole group is kind of like different errors that could creep in with the operator and their interaction with these future AI-enabled decision aids. And then maybe things that were innate to the AI systems themselves, maybe during the development process. So then, as a good systems engineer, I kind of laid across this systems engineering timeline across the top. But the bottom line is that everything over here would be things that would creep in during the development of your AI system, and then everything over here would be things that would happen after your AI system has been deployed and is operational, and now it's being used, either with or without humans in the loop. So we started to just kind of look more deeply at those things. I'm sure this is not a comprehensive list, but this is what we were looking at from the standpoint of systems engineers. And then we started to look at, all right, well, if that's the case, what are some actual solution strategies that we could implement for protecting these AI systems? And again, this demarcation line, things we could do during the development piece. So maybe, hopefully have inherently safe designs or build in extra safety reserves, like kind of thinking in terms of different design trades. And then what are some safe fail mechanisms that might blend over into the actual operational phase? And then there might be some, people or AI systems, automated systems that are going to continuously evaluate these systems to make sure that they are still doing what we intended them to do. So they're not getting off course, or maybe they're not completely failing or doing something unpredictable if they encounter some new situation that they're unfamiliar with. So those kinds of safety issues that could creep in. So anyway, so based on our literature review and just studying all kinds of things that already existed is where I came across this concept of metacognition, where we could take advantage of the intelligence already within our AI systems, and make use of that to help use that to basically assess itself and see whether or not it is actually, doing the intended behaviors that we hoped it would do or not. So anyway, so this is kind of a definition that I think I got from literature, but it's this idea, again, of self-awareness, understanding itself, understanding its external environment, maybe being able to recognize itself that it's encountered something in its environment or some entity that it's not familiar with, and then maybe even taking it a few steps further and maybe reorganizing its goals or doing self-healing or managing itself. So anyway, all right, and then I also found through literature search some of these types of capabilities that when you start looking into them from a systems engineering warfighter perspective are pretty daggone attractive. So being able to just understand the level of uncertainty in the situational awareness, and then being able to use that and take that into account as you're doing your sensor fusion processing and trying to come up with a picture of the battle space. Looking for anomalies and just being able to help detect those anomalies within the AI system itself. Looking at just maybe identifying complexity out of things like just basically, the numbers of threats involved or the tempo of the operational environment or other aspects. And then, being able to go on and maybe even help determine what some desirable or undesirable courses of action might be. If you're an autonomous system or if you're helping some warfighter make some decisions, and then being able to maybe even develop a memory of all of this. Anyway, so on and on, lots of things that would be awesome. All right, so I wrote a couple papers on metacognition that were very high-level concept things, kind of like couching it in a way that could help us with AI safety and so forth, and trying to just start looking at the tip of the iceberg about what this could mean for future warfighters and decision aids. And so that led me, I think, anyway, somehow we connected, and so I was able to write a chapter, I think, at the end of your book on these possibilities for the military. And then I was invited to a DARPA workshop that happened last November, where we were really looking at different methods, and these were not metacognition people necessarily, although many of them were computer scientists, but looking at ways to really tackle developing systems or solutions for managing tactical complexity. So any kind of these situations that a tactical warfighter might find themselves that are very highly complex. So anyway, so based on that, I basically self-selected through that workshop other people that were interested in similar solution strategies. And so right now, like I'm with a group of folks, a small team of like a half a dozen of us that are interested in continuing maybe to do a demonstration metacognition. But these next few slides kind of came out of our interaction over the last 6 months. So we've been really trying to, focus in on maybe some pieces that we could break off. But all right, so this is just this idea. And anyway, we're doing 5 minutes. Okay, no talk fast. Anyway, so this is just one of my concepts from a high level in terms of what's going on in the real world, what's going on in your AI system. There would be another piece where I think one of the strengths of it would be to develop a metacognitive model, internal model to the AI system of what's going on in the real world, and then even modeling what's going on within its own self. So I'm not saying that my picture does a perfect job of representing that, but it was an attempt. And then these are some of the ways that I've been trying to break down system functionality, since I'm a systems engineer, but looking at it loosely, the functions that would help with the self-monitoring and self-awareness, functions that could be done to help with the self-assessment and self-understanding, and then also at some point being able to use all that information and maybe even develop its own goal setting or changing its goals or controlling itself. All right, so now I'm going to just jump in at a very high level real quick and talk about some possible military implications of this. So this slide again came out of that workshop where we're all acknowledging that the battle space can have inherent complexity in it. It's getting more complex as we add more technology and intelligent systems to it. And we need to have some way of hopefully managing this complexity, either through human warfighters or combinations of decision aids and human warfighters, or even intelligent autonomous systems. So some of the concepts that we're focused on that we think that metacognition could help us with is perhaps this idea of reverse explainability. So it's not just always about the human understanding what's going on with the computer and understanding its things, but also at some point, if we're going to have real human-machine teaming, the AI system needs to also trust and understand what the human operators are going to do, what their inputs are, and maybe even detecting when humans go awry. And then at some point, especially with these teams of autonomous systems, having machine trust and explainability. All right, so obviously, as I said, my background is really looking at decision aids, primarily for air and missile defense. So these are some pictures that some of my own student teams came up with, but it's the idea, again, of having AI help with the kill chain. And then if you add the metacognitive piece, that really improves it. Another area would be multi-mission resource allocation. So this is sort of, again, these points in time where the tempo, the complexity might change, but there are going to be some points possibly in conflict where you have lots of either ships or, tactical vehicles or helicopters where each resource could do multiple missions, and how do you prioritize those and so forth. All right, I'll keep jumping on. And then the idea that we could have actual wargaming engines within our decision aids, again, having a metacognitive piece and having that metacognitive memory and internal model would strengthen that. This is just, again, about the AI kill chain. So there's a lot of where metacognition could help in all of these different kill chain decisions, as I said earlier, kind of a another area where I've been focused for a number of years is this idea of cognitive weapons. So we've been applying it a lot to cognitive laser weapons. But the idea is that your weapon system itself could have the AI, could have the intelligence, whether it's innate to it or a separate decision aid. But to make decisions about when to fire a laser weapon, do you fire the laser weapon, or do you choose one of the existing kinetic systems? And how do you do the battle damage assessment so that it's more like a feedback loop? What is some of the new engagement doctrine? How do you take into account whether all kinds of other factors it might be? And then taking it to the further future, what are the implications of something like these metacognitive functions in terms of having possible autonomous kinds of operations. And then I do believe, and this is something we've been discussing a lot, especially with this group that I've been working with, the DARPA workshop, is that we think that this is definitely going to be a stepping stone to in some point getting to something like artificial general intelligence. It's just as far as we're concerned, a necessary piece of getting to whatever that may end up being. And I think that's where I end. So one time, but those are some of the things that we've been thinking about from a high-level systems point of view. So, and it's great to be in on this, I think, from some of it, basically kind of on the beginning of this. But anyway, it's going to be exciting to see where this goes in the next decade or two.
Great.
Yeah.
Thank you.
Do you have any questions? Yes.
Yeah.
Yeah, I do have a question.
Okay.
Hi, this is Huawei from Arizona State
Nice to
University.
meet you. Yeah.
Nice to meet you. I wonder, like, from a system perspective, you say like there are different components, they compound with each other, and in a metacognitive way, do you see the errors or safety measures they propagate, and how do you usually see in a system perspective how do you measure the propagate of like uncertainties or errors or the safety measures? Do you have an idea like how to measure that and how to tackle the propagation?
Well, that's going to be interesting in terms of what kind of system we're talking about, but in terms of an intelligent system, I think metacognition could help us measure that uncertainty as it flows through an intelligent system. And then that begs the next question: who's going to look at the error as it goes through the metacognitive part of the AI system?
Yeah.
So do we need metacognition to do that? That's not really answering your question, but those are some of the thoughts that we've been thinking about. Yeah.
I'm Sergey Nirenberg from AI. So first of all, thank you for laying out the types of applications that we could work on, but I would like to make a metacognitive point, and that is about institutional memory, because we certainly are not the first group discussing metacognition, even within DARPA, because I was a part of a team that was led by the DARPA program director Mike Cox about like early 2010s that was about metacognition, and there was really some discussions of the same types of applications, but with the level of technology that was available then. Yeah, so...
Did you work with Crowder and Freeze?
No, they're different type of...
That was around the time they were publishing.
Yeah, but look,
right?
those people are doing programmatic things. We were actually doing system building. So it's a different type of stuff.
No,
Just
but love
wanted to
talk.
point
Yeah.
out. Yeah.
Sure.